Yeah, spinners and splines and topologies, to cosmetologies on what we're doing inside of here. Well, let's get to the start of her. Now, for me, there's a lot of spinners going on inside of here, especially with this thing because they're all this loop, right? When you think about it like the Halo or the Klein bottle, he does a really good job of describing what he thinks the inside of a black hole would look like. Now think about that for a minute at Sagittarius A star. Well, I just passed the accretion, or the event horizon. What am I looking at inside of there? Well, I'd probably see something really hard and small and fuzzy as far as what it is a real particle watching two neutron stars collide together, or shooting a particle at a wall or a gold slit, right? There's other particles in there, and on the nuclear spaghetti models, some levels going down or coming across, or where you're starting from coming out, or that quantum superposition with some of that wiggly squiggly that comes with it all there. It's just strings. Tying it down. I'm making sure that I control some of the variables so I get that individual nature of it over here to a certain degree. Now that'll cause me problems later, but um, that's why. If you were to say the grid position by what it does with penguins, well, that's a string. That's kind of one of those trying to get the particle accelerator game with a black hole is getting enough of this density going with the mass of it, the radius of it, the color of it to try to order like why they do whatever they do to try to recognize some patterns or some kind of oscillation overall with it that says I found the sorting algorithm big one, and that's the most of that fuzziness that's in there before I can't really tell past the atom. That makes it at the millionth some level of a shell variable. Because blue light and peacock feathers or something, it's not something you'd do. So if you're doing Necron technology, they're in some probably why it's like sodium or it's not sodium and triple alpha issue. Anyways, sorry about that tangent. These are strings. I'm just describing a topology. It's A. When it is A, there's other versions of it not being A or any different variable of what that does, and I might need one or two different models to be able to explain that, or where I'm putting some point, some issue that says it's lens. This one moves a little faster. This one moves a little slower. There's some kind of system inside of there, so that's universal, and it's all moving right. Why? Why? Because, well, all this, and there's trying to figure out like, well, if there's different topology of being, here, then that inversion is all these other states. There's going to be like, well, A moved in this momentum, but if A had a different mass because of atoms that it shares in the packet, well, then there's going to be a different spinner inside of there. Now, again, exactly where we are in it all about whose science makes it visibly understandable of uncertainty. You get a source code like that. It's going to be XYZ, but realistically, it's hard with topology to sometimes tell them apart if you don't know what you're looking at. And you bend it such in the right way that it looks like the optics of a thing, and you say that there's a movement or a period or a joule inside of there because Brownian mechanics and it breaking down. Browning was botanist, okay? Probably a lot of this kind of stuff was involved with what you're doing on a Rhodes conjecture AUAX. There's a derivative of U or A of U that's some kind of infinity triple position. It was a little bit yesterday. What you think that's going to do today, how that changes in a system, which is a gold standard or marginal utilitarianism of silver and gold. The name and its concept. If I use gold, then that's fine. If I only had as silver as something that does also those things, but I didn't have the cookbook recipe, what would be the effects? What would be the AX, that $5,000 check I'd award you for the STEM game on that week, right? Some special kind of program on wrong one first here. What do we got a little out of order there? Anyways, coming in there. What do we got over here? This one's Vermont's. which is the a plus b equals c kind of thing, Pythagorean. Going to get me into the squared bit of that, which gets me up and right, or inverted negative numbers, because, again, time dilation wise, that doesn't make sense to do that except for from the experimental criteria. -1 was experiences where x was that. When b had those experiences too in field charge, would that cause the field charge to be a up signal? For me, again, in the orientation here, that's the concept I'm looking for to any other CX notes that come with that. Specifically, what did I say over there? Yeah, Y and Z, X, Y, Z. So, and collusion, I want to towel off into that infinity from the Big Bang source over there. And that might be what that is. There's nothing to say that it couldn't, or because they got close to each other, it pinched off, or, who knows. I just want to cover Beals here. We'll get to, I think this one's Beals. Command directive. No, that goes to those other ones. NP, always fun. That's a number problem. But again, an organization of field theories. It's Fermat's, Rhodes, Fermat's, and Beals. Bang, bang, and bang,
Start with that first word, quantum. Simply put, quantum is derived from the same root as the word quantity. It's the strange principle that, on a small enough scale, the universe seems to work in discrete quantities rather than operating on one continuous scale.
I could probably crank it out.
This is a little unintuitive, much like many things in quantum mechanics. So let's illustrate what we mean with an example. If you are running, I could ask you to half the speed you're running at. You could half your speed again and again and again. Is there a limit to how many times you can half that speed? While you might struggle with the precision necessary to do it, in classical physics, there's no reason you couldn't keep halving and halving your speed indefinitely.